Welcome to Study Loop.
Okay, folks, so in this video we're going to be talking about this problem. A particle of mass 6 grams moves at 4 kilometers per second in an xy plane in a region with a uniform B field given by 5 megateslas in the i-hat direction. And at one instant, when the particle's velocity is directed 37 degrees counterclockwise from the positive direction of the x-axis, the magnetic force on the particle is 0.48 newtons in the k-hat direction. So we're looking for the particle's charge. Okay, so let me just draw this problem out for you. If you have an xy plane, let me use a different color for the B field. The B field is uniform, and it points always in, like in the x-hat direction, because I-hat is y-hat. I'm sorry, I-hat is x-hat. At one instant, when the particle's velocity is directed 37 degrees counterclockwise, I'm not a great artist, but I can probably tell that this is around 37 degrees. Due to my limited artistic capabilities, but yeah, this is roughly 37 degrees. When the particle's velocity vector looks something like this, we are given that the magnetic force at this instant is 0.48 newtons in the k-hat direction, okay? So let's recall, I just want to remind you, what is the force? What is the magnetic force on a particle? The magnetic force on a particle is given by this equation, Q times V cross B. This is the magnetic force on a particle, and this gives you a vector, and the magnitude of that vector is QVB sine theta, and the direction of that vector, we don't really care, because, well, we do care because it's in the z-hat direction. Because if you do your right-hand rule, you wrap your finger from V all the way to B, you will realize that, well, let's do that. I don't want to, brush over that because this is actually kind of an important thing. If you wrap your finger, if you do your right-hand rule with this V and this B, this is the velocity, this is the velocity vector, and this is the B vector. If you do your right-hand rule, V cross B gives you a vector that is supposed to be pointing into the page. It's supposed to be pointing into the page, but it's not. In this problem, the force points out of the page. That means the charge better be negative, because if the charge is positive, this magnetic force is going to be pointing into the page instead of out of the page. So this Q, so we know that Q is less than 0. It is a negative charge. It is negatively charged, okay? So now we want to know what is the magnitude of this charge, because we already know its sign, it's negative, but what is the magnitude of it? Well, we know the magnitude of the force. I'm sorry, that was a mouthful. We know the magnitude of the force is 0.48 newtons, right? And that means if we figure out what Q is, we are trying to figure out what Q is. If we figure out what V and B and sine theta is, then we can, do your algebra and move everything to the right-hand side and find Q, okay? So do we know about its velocity? Well, actually we do. It is V equals 4 times 10 to the power 3 meters per second. Do we know the B? Well, we do, because B field is 5 megateslas. And do we know about the sine theta? Well, we don't, but we know theta, because theta is 37 degrees. So now we know everything. We can just plug everything in here. We get Q equals 0.48 divided by VB sine theta. We know V, we know B, and we know sine theta. We can calculate everything. You can just plug everything into your calculator. You will find the answer. And I'm not going to do that here, but I encourage you to, verify the answer by yourself, but let me just tell you that the answer is -4 times 10 to the power of -2 coulombs. Okay? This is the answer to this problem. -4, like I said, it has to be negative. -4 times 10 to the -2 coulombs. Okay, this is the answer. I will see you in the next video.